Okay, so we're going to look at the conjugate zero theorem. Fx be a polynomial with real coefficients. If the complex number z is a zero of f, then its conjugate z bar is also a zero of f. So we have to be aware that when we have a complex zero, like we have here in this problem, 3 plus I, that means that 3 minus I is also a zero for our problem. So when we find a polynomial with these real coefficients, then we need to take into account that if there's one complex zero, then there is two of them. So we look to find this. So we have f of x equals. And the last couple problems we've looked at, we've used, had k here for a constant that goes in front, and then x minus 2, x minus the quantity 3 plus I, and x minus the quantity 3 minus I. Remember, we're using the opposites when we're doing the zeros and put it in factored form. And so in this case, they don't give us an x value and a y value like they have in previous problems. So we don't need the value of k. We're just going to assume that it's 1 for this problem. Okay. Now, the next thing we're going to do is we're going to simplify this. And we will work with the complex coefficient factors first. So we've got the two factors, x minus 3 minus I and x minus 3 plus I. And since those are harder to work with, we're going to go ahead and multiply them first of all to help us out. And it'll make it much easier when we're in the long run. So we've got our x minus 2 here. And then we're going to multiply these. And we'll start by multiplying x by all three of these. Right? So our standard, similar to FOIL. So we get x squared minus 3x plus ix. And then we will multiply the negative 3 by all three of them. So that'll give us negative 3x plus 9 and minus 3I. And then we'll multiply the negative I times all three of them. And so that'll give us negative ix. And I'm actually going to write that down here. And positive 3I. And I'm going to put that over here. And negative I squared. So now when we combine that and simplify it, we have x minus 2 still. And then we have x squared. We have a negative 3x and a negative 3x, which gives us negative 6x. But then we have positive ix, negative ix. So that's 0. Negative 3i and positive 3i, so that's 0. So whenever you have just an I, it's going to, all those terms are going to cancel out. And then we have positive 9 and negative I squared. So since I squared is negative 1, that becomes a positive 1, so we have plus 10. And so now we can see that we have this factor here, x squared minus 6x plus 10, now has just real coefficients, and there are no complex numbers there. So we don't have any values, any i's in it. So we would go ahead and we'll finish this out and do the final multiplication, and we'll end up with x cubed. So f of x equals x cubed, and then we're going to have negative 2x squared, negative 6x squared would give us negative 8x squared. And the positive 10x and negative 12x. Positive 10x, positive 12x would give us positive 22x. And then negative 2 times 10 is negative 20. And there's our polynomial. But the thing to notice about this is that, as like it says right here, that this technique used in example 3 works because the product, x squared minus 6x plus 10, has real coefficients. And that would be our solution for this problem.